Looking over there, I'm like, I think that was Ian.
Yeah. The thing is, he moved towards the ball, not away from the ball.
That sounds like Ian.
Yeah, it's Ian.
Algebra 1B. Okay, actually, I'm off by a day. Okay, but we're gonna be solving equations by adding and subtracting. We're gonna be solving equations by adding and subtracting. You guys remember one-step equations last year with Mrs. Springer?
Yep.
Okay, we're gonna be working on some of those today. Okay. So we're going to work on the ones solved by adding and subtracting, so we'll be in 0.4. So this is the bottom of the page where we left off on last. Make sure you have your notes out. Make sure we have our notes out. There we go. Alright. So, this should be a review here, right? We're going to solve the equation, then we're going to check our solution. So if you have r minus 8 equals 32, how would we solve that equation, Olivia?
So you would put a line through like the equal sign.
Okay, so that's a good tip. You put a line through the equal sign.
And then you bring the 8 under both of them, and so that would make like that you would wait for. I'm getting ahead of myself.
Cross the river. You got this, girl.
So you would bring the 8 down on both sides.
Okay.
And I think it would be negative because it's a negative.
Well, how do we get rid of negative 8? How do we offset that?
Wait,
Huh?
no.
How do you offset negative 8? Because we want to get negative 8 back to 0.
So, I don't remember.
Okay? Negative 8 plus what is 0? 8. So if we add 8, what's going to be negative 8 plus 8? 0. Do we have to write r plus 0?
No.
No. So, that's how we move it to the other side, is you add 8. Now, why are we adding? What's the one way we can say we know we're adding? What's the opposite of subtraction? Addition. So we're going to do the opposite of whatever is here to undo something, okay? When you're trying to undo something, a lot of times you have to do the opposite of it, right? Okay? It's like if I move something too far, and I want to undo that, I have to move it back. Well, I don't want the subtraction to be here because I want r by itself. So I have to undo the subtraction by doing the opposite. So I'm going to add. So now I have r on this side because my 8s, I went to 0. R equals, what's 32 plus 8?
40.
40. Yep. And we have to keep it balanced. We have to keep the equation balanced. So we have to add 8 to both sides. We get r equals 40. Now, how do we check our solution? Somebody help me on how we do that, Abby?
You plug in 40 where R is supposed to be,
Yeah.
minus 8.
So you plug in 40 for r and say 32 or 40 minus 8 equals 32. Now something I do is we're trying to ask a question here. We're saying, does this equal? So I'm going to put a question mark above it. I'm going to say 40 minus 8 equals 32. Guys, when you ask a question, right, you inflect your voice a little bit. Like, hey, where are you going? Like you have your voice go up a little bit at the end. And does anyone notice you do that? Yeah. So it's the same kind of thing. So I always just say 40 minus 8 equals 32. So what is 40 minus 8? 32. So what does 32 equal 32? So I always say, check, it checked out. We're good to go. Check, it checked out. We got the right answer. Now, during homework and tests and quizzes and everything, I'm not going to make you check your answer, but if you check your answer, do you know whether you got it right or wrong? Yeah, so it's pretty handy. It's pretty handy to know how to do. Okay? Then you want to keep that away though?
Yeah, I'm using my calculator.
Yeah, we're going to try not to use calculators during class the best we can, okay? So, next problem. H minus 12 equals negative 27. So, we can draw the line through this every time. We don't have to if you don't want to, okay? That's a great organizational method though. But if you want to keep drawing this line through the equal sign, you definitely can. You don't have to, okay? So, here, what's happening to H? What's happening to our variable H? We're doing what operation to it?
Subtraction.
Subtraction. So how do we undo subtraction? Okay, Tobin.
Addition.
Addition. So what are we going to add to both sides here, Olivia?
12.
12. Now, why are you saying we're going to add 12? I agree with you, but why?
Because it's like the smaller number, and you can, well, and
Can anyone help Olivia on why we're choosing 12? Okay, why aren't we adding like 8 or something like that, Maddie? Okay, because that's what we're subtracting by. And we're gonna add by what we're subtracting by. We're gonna do the exact opposite, subtracting 12. The exact opposite of that is adding 12, the same number. Now can I just add it to one side?
No, you have to add it to both
So I
sides.
have to add it to both, very good. Okay, so what's negative 12 plus 12? 0. Gone. We took it away from this side. So we just have h equals, now we have negative 27 plus 12. Negative 27 plus 12. What happens when you have two different signs, a negative and a positive? Olivia?
What do you call it, the bigger number?
Okay, the sign is of the bigger number, so it's going to be negative or positive.
It's gonna be negative.
It's going to be negative because 27 is bigger than 12. And how do we know what our answer is? You subtract them. When they're different signs, you subtract them. And you just take the sign whichever number is bigger. So what is 27 minus 12? It'd be negative 15. So our h is equal to 15 is our answer. Now we go back through and we can check this, right? So we plug it in for h. Negative 15 minus 12 is equal to negative 27. And I'll say equals. It does. Okay. Now negative 15 and minus 12. Okay, are those the same sign? I can see your house. Yeah, I'm so offended. So what happens? I heard someone say, what happens when we have two negatives?
You have to add.
You add them, same sign, add, and you keep the sign. So what's 15 plus 12? 27, but it's a negative 27. So does negative 27 equal negative 27? Yep, check. It checked out. Okay. Questions on that? All right, let's try this next one. Okay, I want you guys to actually try this next one on your own. I want you guys to try this next one on your own. So let's do 5 equals x minus 10 on your own. If you have it or have questions, raise your hand. Number 3. Yeah. Very good.
I'm Papa Tucker. Or Tucker. I had the T right,
Oh,
right?
okay, you're over that. Very
Okay. You have to add the 10 to 3.5.
Hey, be careful, guys. It's not 3.5. This is number
Oh.
3, and it says 5 equals.
Oh, okay, then you're right,
Yeah.
I apologize. You're right, I thought it said 3.5, so I'm,
Wait,
so I did it wrong.
So,
Yes.
so, which one? Opposite or would that be
Yeah.
See, it makes a lot of things a lot easier.
It does.
It makes it a whole lot easier, I did 3.5. You get it, Joe?
Yeah.
Okay.
There you go.
I'm not done yet.
All right, we'll talk about this one up here. So, what would we do here in this problem? Tucker, add 10 to both sides. So we have x minus 10. Let's add 10 to undo the subtraction into both sides. Now it's 10, 5 plus 10.
15.
15. We still have our equal sign here. If you want to build a line through to help remember that, you can. Okay? X is still here. What's negative 10 plus 10? 0. Negative 15 equals x. X is by itself now. Now we can go back through and check, right?
Yep.
Okay. So 5 equals 15 minus 10. What is 15 minus 10? 5. Does 5 equal 5? So if it checks out, check it, checks out. Okay. Questions on that? All right. Okay, let's go on to number 1 right below this. What are we doing now instead? Instead of solving by addition, we're going to be solving by subtraction. Are we doing the same kind of idea though? Yeah, I think we are, okay? So I want you guys to try number 1. And if if you have any questions, raise your hand, or if you have it, go ahead and raise your hand as well. We did do all of them. We're just doing number 1 right now. All right, let's talk about this one up here. So k plus 63 equals 92. K is not by itself. We want it by itself. So how do we undo what's happening with k? How do we undo the addition of 63?
Yes,
Gotta subtract 63. Subtraction is the opposite of addition. So we're gonna subtract 63 from both sides. Gotta be equal, okay? So what's 63 minus itself?
0.
0, just k on this side. Equal sign. Don't forget about that. If you want the line there, you can put the line there. 92 minus 63. What is it, Tobin?
29.
29. I agree with you. K is equal to 29 here. Now let's check our solution just to be careful here, okay? Once again, I'm not going to make you guys do this on homework or tests or quizzes, but it's a good idea if you have the time, okay? So 29 plus 63 equals 92, okay? So 29 plus 63, does anyone know what that does equal? Okay, let's go over the side you got. What's 3 plus 9? 12, so 1 and 2 down below. What's 6 plus 2? 8 plus 1? 9, so is it 92? So does it check out? Yeah, 92 equals 92. Check, checks out. I want you guys to try number 7. Any idea when you're done? Or questions for you can? Good.
Yeah.
Did it again. I did it. You're right. I never read it. Yep. Tobin's right.
Very good.
Yes.
Now, are you communicating to you? When I'm talking to another student, is Hasmus talking to you? Okay.
Okay.
Very good. We'll talk about that later. So on number 2, let's talk about this one up here. 7 equals 42 plus t. What's going on with our variable? We're doing what with it? It's being added with 42, isn't it? But what we're going to do to fix that is subtraction, okay? So I'm asking the question before that one. Is what's happening with our variable? We're adding it with 42. How are we going to do addition? Subtraction. So we're going to subtract 42 from each side. We're going to subtract 42 from each side. If you want to do that line with the equal sign again, you can. So we have 7 minus 42. Are those same signs or different signs? Different. A positive 7 and a negative 42. So we subtract them. What's 42 minus 7? 35. Which number is bigger though, the 7 or the 42? So it's a negative 35, right? 42 minus itself is 0, we got rid of it. Now we're left with t. So negative 35 is equal to t. And we're done with that problem. We'll check it though, just in case.
I think we need to next year do the little parentheses instead of the dots. Like 2.7.
Oh, first, okay.
Because to me, it looks like I've done it every time, 2.7, so I'm making it harder than it has to be, and then it's shocking, but maybe it's just me too, so.
No, I understood it.
Okay, no, yeah, that's, thank you. I mean, good feedback for darn sure. Alright, so 7 equals 42 plus negative 35. Okay, what's 42 plus a negative 35? Those are different signs, so we subtract them. What's 42 minus 35? 7. It's still positive because 42 is bigger. So does 7 equal 7? Check, it checks out. Alright, let's try number 3, okay? Let's try number 3. Once again, once you have it or have questions, raise your hand. Ooh, lots of hands go up.
On the moving.
You guys working ahead a little bit. Good for you.
Okay, what are these? Okay, so you take a negative plus a negative, you get a negative number.
No.
You're taking 21 away from it, so you add it together.
Yes, ma'am, it would.
For multiplication, you do 2 negatives.
Yeah. So let's talk about this up here, guys. What's going on with our cube? We're adding what to it? 21. Now we want to undo adding 91. So we're going to do what with 91?
Minus.
Subtract it, minus, okay? Let's subtract 21 from both sides always. 21 minus itself is?
0.
0. Q equals, are these the same sign or different signs?
Yes.
Same. Same sign, add, and you keep the sign. So what's 18 plus 21? 39, but it's negative, right? Because we're keeping the sign. So negative 39, and we'll go through and yep, we'll check it again. So 21 plus negative 39 equals negative 18. Or I should say equals negative 18. So 21 and negative 39, same or different signs? Different. So we subtract from 39 minus 21. 18. And 9 minus 1 is 8. 3 minus 2 is 1. 18. But it's negative because 39 is bigger. Does negative 18 equal negative 18? Yeah. Checks out. Questions on these? Okay, continue on to the next page. We have a little bit on this back, okay? What color should I pick?
Light blue.
Light blue. Okay. So, solve y plus 4/5 equals 2/3. Ooh, fractions. Fractions. Gross fractions. Okay? So, we'll work through them, though. We'll figure them out, okay? So, what would we do? Well, let's first of all say, is y by itself? No. What's happening with y? Added. With 4/5. So, how do we get rid of addition? What are we going to subtract by? 4/5, exactly what's there. You're nailing it. Now we're going to do that on both sides, right? Now here's the thing. What's 4/5 minus itself? 0. Anything minus itself is 0. Now, do we know off the top of our head 2/3 minus 4/5? Does everyone, you guys don't have that memorized? What? No? Oh, okay, me either. Okay. So 2/3 minus 4/5. What do we need in order to add and subtract fractions? Common denominators. You guys are nailing this. Mrs. Springer must have done really well with your hands, okay? So what's going to be our common denominator here? Do we know? Abby, what are you thinking? 15, yeah, we can multiply both to 15. So what are we going to have to multiply the first one by to get to 15?
5.
What about the second one?
3.
3. Okay. Now, is that just multiplying it by each other? Right? Or, excuse me, is that, so see how the denominators are both 3 and 5? A little trick is you can always multiply one by the other, and you'll always get a common denominator. It just might not be your lowest one. You might get bigger numbers than you need. Okay? Now, you guys can do this a few different ways. Something I'm going to have you guys do, and something I'm going to have you do, or I'm going to show, I should say, is I'm going to multiply this one by 5 over 5. Multiplying by 5 on the top. Multiplying the one on the left, on the one on the right, excuse me, by 3 over 3. I'm going to write that little dot, I'm multiplying it. I'd recommend writing it a little bit smaller than normal numbers, so that way you try not to confuse them with your normal numbers, okay? If you want to, you can also do this off to the side and say, okay, I'm going to do 2/3, and I'm going to multiply this by 5 over 5, and say, okay, what's 2 times 5? 10. What's 3 times 5? 15. And say, okay, now I need to do 4 over 5 times 3 over 3. What's 4 times 3? 12. What's 5 times 3? 15, okay? Is that easier for you guys to do it off to the side or do it in the problem? What was that?
I think we'll have the same result.
Yeah. Now let's keep going then and talk this through. So either way, right here, we'd end up with 10 over 15 minus 12 over 15. So whether you guys want to do this inside the problem or outside the problem, like there, either way is fine. So the red part you can do in either spot. The red part you can do in either spot. Now how do we combine these? What would 10 15th minus 12 15th be? Are those same signs or different signs? Different, positive, negative. So we subtract what's 10 minus, or 12 minus 10? 2. Which one's bigger? 12, so it's negative, right? So this is y is equal to negative 2 over what? 15. The denominator stays, right? We just did all this work to get common denominators. Let's not throw it away now. We just did all this work to get common denominators. Let's not throw it away now. Okay? Questions on that? Okay? Ooh, fractions, right? We love them.
Was that negative 2?
Negative 2 over
2/15.
Yep, negative 2/15.
Okay.
Yep. Okay. On number 2, 1 is equal to x plus 0.356. We got some decimals here. As we also threw in some decimals. You thought you'd like those, okay? I'm not going to make you check on number 1 though. Be good. 1 equals x plus 0.356. So what's happening with x? What's happening with our variable? We ask ourselves this question all the time. What's happening with our variables? Added. How do we undo it? Subtract. So what are we going to subtract by?
0.3656.
No, we're going to subtract by a decimal there, right? On both sides. Okay. Now what's 1 minus 0.356? Anyone know the top of their head? No? Okay, that's okay. I was kidding. Yeah, I don't expect you to. So what we can do is we can put 1 and then just write it up above here. But we're going to line up, right? So the ones, they're going to go right above the 0. So we're going to have to put after this 1.
Zeros.
Zeros, and we're going to have to put a decimal there, right? Very good, Maddie. Now can we do 0 minus 6? No, we're going to have to borrow, aren't we? Where are we going to have to borrow all the way from? 1. 1 over here, the 1 becomes 0. The 0 becomes 1, but then it becomes a what? 9 again. This becomes 10, then it becomes a 9. This becomes a 10, and this becomes a 9, and this becomes a 10. So now we have 0.9910. What's 10 minus 6? What's 9 minus, I'll slow down a moment. Good? Okay. What's 9 minus 5? 4. What's 9 minus 3? 6. Now we have our decimal. 0 minus 0? 0. So it's 0.644. Equals x, and what's 0.356 minus itself, guys? 0, we got rid of it. So our answer is 0.644, or just 0.644 if you'd rather, is equal to x. Questions on that? Okay. So decimals and fractions, are they impossible for us to do? No. Is it a little more work sometimes? Yeah, it's a little more work, but we can still do it. Okay. Let's look at number 3. A plus 1 equals 2 sevenths. A plus 1 equals 2 sevenths. Okay? What's happening with our variable A? Adding. How are we going to do it? Subtraction, right? What are we going to subtract by? 1. A is equal to 2 over 7 minus 1. Now, we have to get what in order to subtract these? Common denominators. Now, what's the denominator of a 1? We don't see anything there. 1. It's always over 1, isn't it? Any whole number is over 1. Now, we can do this work on the side or once again inside, but what's our common denominator going to be? 7. You guys change our first one at all? No, what do we got to do to the second one? Multiply by 7 on the top and the bottom, right? Maybe don't just want to leave part of it out. We have to multiply the top and the bottom. Okay. Multiply the top and the bottom by 7 there. So now we're going to have A is equal to 2 sevenths minus what? 7 over 7. And what is 2 sevenths minus 7 sevenths? 5, what are you thinking? What kind of 5? Negative 5 over 7. Because what number is bigger, the 7 or the 2? 7, so we say it's negative. Okay? So they're different signs, positive and a negative. Subtract them. 7 minus 2 is 5, but the 7 is bigger. It's negative. And we always keep the denominator. Once again, we just went to all that work to get common denominators. We're not going to screw it up, so we're going to save it. Question on that? Alrighty. So, do you guys remember how we had all these expressions before? And then we turned them into algebraic expressions? We're going to practice the same thing right here on number 4. We're going to practice the same thing here on number 4. 14 more than a number is equal to 27. 14 more than a number is equal to 27. Find the number. Okay? Who can help me with this one? Lainey.
Do you want me to tell you like the equation?
Yeah.
14 plus x equals 27.
Exactly right. 14 more than a number. 14 plus. More than means plus. We can always go back to 0.1 and check that out in our table. A number means a variable. Lainey chose x. Is equal just means equals 27. Now we're asked to find the number, find the variable, right? Can you guys solve this one? I think so. Okay, go ahead and solve this one for x. Once you have enough questions, raise your hand.
Oh, sorry. Yep, you're good. Reagan, you're wrong. Just teasing. I'm teasing. You're good. I'm just funny with you, sweetheart. You're usually never
so
really good at these math.
I'm really good at these and you're so really bad.
How do you do on multiplication and division?
Okay, or Foxo.
Yeah.
Is that where the buildings are on?
I think so.
How is it actually?
It's actually,
Close to an hour, yeah.
like, just about 2:30.
So 14 plus x equals 27. So how would we solve this? Wait, Olivia?
You would subtract the 14 and then you would subtract the 27 from 14 and that would give you x equals 13. Positive 13.
Yeah, positive 13 because they're different signs to subtract. 27 is bigger though, so we say positive.
Mr. Foster, can I just tell you how proud I am of that girl?
You betcha.
That the whole draw the line, because she was speaking my language, because she would get confused, so that's why we always drew the
Yeah.
line. And now look at you, you don't have to draw the line, Olivia, I'm so proud.
Good stuff. That's awesome. That's awesome. We love success stories. Any questions on number 4 here? All right, we got one more problem today, okay? One more problem today.
Yeah.
Oh.
It's alright, I'll
It's
be
a
with
word
that.
problem.
Not
Okay.
that bad.
Hey, what color should I pick though for this
Ooh,
one?
fun.
Pink, red, pink.
You know that pink right there. Oh.
Yellow,
There you go.
blue, yellow.
You need to
Family
yellow.
I don't think it wants you to sound
Okay.
that color.
What color should I pick?
Blue.
White.
Blue.
Not light pink.
White.
Yes.
You can't do the equation if it's white, buddy.
Okay.
I mean, you can.
The Washington Monument in Washington, D.C. You guys know what the Washington Monument is?
Yeah.
It's the big, tall one.
Yeah.
Was built in 2 different phases. So it was built part of it at a time, and then they had to stop construction, and they built more of it.
Okay.
During the first phase, the monument was built to a height of 152 feet. During the second phase, additional construction resulted in the monument's final height of 555 feet. How much of the monument was added during the second construction phase? Write an equation to solve the problem. Now here's something I like to do with word problems, okay? Here's something I like to do with word problems. Is I like to go through and underline key information. So raise your hand if you think you know something in this paragraph, in this word problem, that might be key information. Emily.
During the first phase, it was built.
Okay?
I like first phase and then underline 52.
Ooh, I like that. Okay, so Emily was saying, hey, during the first phase, we need to know it's built to 152. So we don't have to underline the whole sentence. Let's underline first phase and 152 feet. That way we know that's the initial, okay? I love that. You can shorten down or underlining, okay? Tobin, what's another piece of key information?
During the second phase, it was built to, the final height was 555 feet.
Okay, so we kind of have a couple things in there. I think we can even break that apart into 2.
Yeah.
Break that apart into two different ones there, okay?
Underline, second phase, and
Okay.
then the 555 feet.
Okay. Let's actually go second phase and then underline something else with second phase. And then tell me what I would want to underline second phase besides 555. I think we're gonna save that for another thing, okay? Reagan.
Additional.
Additional. Second phase, additional construction, okay? And then what's the other thing we want to underline with the 555? Because Tobin's right, we want to underline 55 feet. What do we underline with that? Okay? What do you think, Delaney?
Final height.
The final height, okay? Now, we're trying to figure out how much was added during the second construction phase, right? That might be important to know, okay? So how much was added, okay, during the second phase? Okay, during second phase. That's probably pretty important, right? Okay? And tell us to write an equation. Can anybody help me write an equation, especially now that we went through and underlined some key information, okay? Abby.
152 plus A equals 555.
That's exactly right. Can you tell me why you got that?
I got that because the first phase was 152.
Okay,
Then it says additional, so
Yep.
you add,
okay.
but you wouldn't add 555 because we want to know how much was added during the second phase.
Mhm.
And it says final height, so that would be the final. So you put A, and then equals 555.
Very good, very good, very well worded. Any questions on how we got that or how Abby came to that? That's exactly right. Now, do we have to use A? Could we use a different variable?
Yeah.
Sure, we totally could. A is just fine. And now can we solve this one?
Yeah.
Yeah, because what's happening to our variable?
Getting added.
Added. How are we going to do that?
Subtract.
Subtraction. Aiden, what would you subtract? What would you subtract? We said we need to subtract. What would you subtract? Would you subtract A? Okay. You subtract 555? Okay. Is that what's with the A right now?
Oh, wait, no. Sorry, subtract 150.
Okay, very good. Why'd you change your mind?
I got cooked around.
Okay, okay. So we want to subtract whatever's with the A. What's 152 minus itself?
Oh,
0. Oh, I got you there, Tucker. Now 555 minus 152. This is kind of convenient. You can go straight down. Olivia?
2? No, 3. Wait, what was the question again?
555 minus 152.
Oh, 403.
403. Oh, you were doing 5 minus 3,
Yeah.
you know?
She was doing the problem with
Yeah, you were going with me. 5 minus 2 is 3, 5 minus 5 is 0, 5 minus 1 is 4. And now this is 403 chickens, 403 ducks, ostriches, canoes,
Feet.
feet.
Thief.
Oops. We don't want to forget our label. So how much was that during the second phase? 403 feet. Okay? Any questions on that? You guys are rock stars.
Yay.
how much different it is, how fast we can get through notes when everyone's quiet and pays attention, huh?
Isn't it crazy?
Yeah.
Oh,
That's
that's such a
Oh
stressful
my
year
God.
for new freshman year. Math class.
Oh, that's stressful.
Mine is it?
Wait, what?
What was it?
Well, two
Math
things, guys.
last year, but I didn't understand.
Yeah.
Once I go home, I'm taking
Me
a
too.
nap.
I've already told this There's always reminders that you have no
What?
idea, and I never eat. I'm like,
I love that.
I've been tough for years, like, I guess.
Oh, yeah. Yeah, I remember that.
Oh, wait, yeah, you were there.
Yeah.
Olivia, you should have seen how
Well, then I
proud
did.
my heart was
So
when you
you,
said,
oh, it wasn't. Oh, you
roll the
were.
line.
Alright. Hey guys, do you want to do all of these?
Sure.
No.
Don't? Okay. Don't do 16 through 20.
Yay.
I mean, you can if you want to, but it won't be up to credit. So, don't do 16 through 20.
Is it okay with the music?
You can listen to music. And if you want help at all during this, or raise your hand, come talk to this Haskell or myself, okay? Yeah. All right, let's look over here at the sideboard. Algebra 1B on Trooper Tide Tuesday, the 25th of August, the funniest day of the month, 25. Okay, SWBA students will be able to solve equations with multiplication and division. So we're going to be in 0.5 today. We were in 0.4 last time, right? Okay.
And stop it.
Dave, you have the phone over there? He's like, yes, I was. Before you stopped me. Okay. So we're gonna solve these equations with multiplication. Okay. So we're gonna solve the equation, check the solution. So S divided by 12 equals 3. S divided by 12 equals 3. Okay.
Can I start just like,
I thought you leave it. Do you dismiss at 12:15 though, or do you leave it?
I don't know.
Yeah, I think you dismiss it.
Yeah.
Yeah, 2:15.
I don't wanna go back and start until 1 o'clock in the afternoon.
Yeah. Ooh. So S is being what by 12? What operation is happening between S and 12? Division. How do we undo division? Multiplication. So it's being divided by 12. What are we going to multiply by? 12. Or a 12 over 1 if that makes it easier for you. A lot of people like to put that 12 over 1. So we have a fraction with a fraction, okay? What can we do with this 12 and this 12? Cross them out. We can simplify them. Because does 12 go into 12? Once. Does 12 go into 12? Once. Then we have to multiply this side by 12 as well. Now you can do 12 or 12 over 1. They're the same number, aren't they? So does it matter? matter whether you call it 12 or 12 over 1. No. Have you guys ever heard the phrase 6 in one hand, half a dozen in the other? Okay. So how much is half a dozen? 6. So if I have 6 in one hand and I have half a dozen in the other hand, how much do I have in each hand? 6. I have the same thing in each hand, right? So that's just what the expression means, is 6 in one hand, half a dozen in the other. They're the same. It doesn't matter, okay? 12 and 12 over 1, they're the same. Doesn't matter. So now over here, 1 times s is s. 1 times 1 is 1. So s over 1. Do we need to write s over 1? No, it just becomes s. Okay? That's just the math behind it. What is 3 times 12? 36. So s is equal to 36. That would be our answer, okay? And then we would go through and double check it 1 second before we go through and clarify some stuff, okay? So to double check it, we can plug in 36 for s. 36 divided by 12 equals 3. Remember I did the inflection there. Okay? Equals, okay? What is 36 divided by 12? It is 3. And 3 equals 3. Boom, it checks out. Okay, Aiden, you said you were confused.
Yeah, and I realized it was division. That was a fraction.
Well, fractions are division.
Well, right, but I thought it was like, I don't know, I thought it was different.
Yeah, so fractions and divisions are really the same thing. A fraction is a division problem we're too lazy to do. That's the one thing I heard a math teacher say one time, and I'm like, that's pretty accurate. Like negative 1/3 over here, that's the division problem. We're just saying we don't want to actually do that because it's just 0.3 repeating, and this is actually nicer and neater than that. We're going to be too lazy to actually go through and say, this is 0.3 over and over and over and over and over again. On number 2, 1.8 equals 2 divided by 2. 1.8 equals 2 divided by 2. Or w divided by 2. What is happening with our variable w? Being divided by 2. How do we get rid of the division? Multiply by 2. Or 2 over 1, right? Okay? So 2 times 1.8 decimals, okay? Well, think about it this way. What would 2 times 18 be? 36. But now you have to put the decimal back in. 3.6. Decimal's not that scary. What happens over here with our W, our 2's and everything? Yeah, they simplify. I'm going to be mean. I don't like the word cancel, okay? In math, things don't just cancel and go poof. Okay? There's some math behind it. They both reduce to 1. Cancel means they go away. They don't go away. It goes to 1, which you don't see. Okay? It goes to 1, which you don't see. Okay? I'm going to be mean about that. So then we could say, yep. Don't tell it. No. So we can go through and check 1.8 equals 3.6 divided by 2. You might not know 3.6 divided by 2. Do we know 36 divided by 2? What is it? 18. You gotta put the decimal back in. Does 1.8 equal 1.8? Does. Check. It checked out. Questions on that one? Okay. I want you guys to try number 3 on your own. N over 3 equals negative 2 over 5. Okay? When you have it or have questions, raise your hand, and this is how I'll come around to luck today. Well, may the course be with you. Yep. And if you want to leave it as an improper fraction or a mixed number, either is okay.
You lost your sign. Oh, you got it.
So would I multiply 3 by
You got 1. It is by 3 over 1. What are you asking?
don't you need,
Yeah.
See, so we only need
No.
No.
What?
Since this is division, you
Yeah.
want to get this out of the denominator, get it out of the denominator, now what is my straight class?
Alright, let's talk about this one up here. So n is being what right now? What's happening to it? Divided by 3. How are we going to do that? Multiply by 3, the same thing. Or 3 over 1 if you prefer. Multiply this by 3 over 1 as well, or 3. So this 3 and this 3 reduce, and it just becomes n. Now, negative 2 over 5 times 3 over 1. We don't need common denominators, we just multiply straight across. Negative 2 times 3 is
6.
6, but a negative, right? We have a this is a negative fraction because the negative times the positive will be a negative. What's 5 times 1?
5.
Negative 6 over 5. That can be our answer. If you want, you can make that a mixed number. What is that as a mixed number, Abby?
Negative 1 and 1/5.
Negative 1 and 1/5 as a mixed number, okay? Questions on that? Alrighty. If this will be handy for our next examples. If there's a fraction in front of the variable, multiply by the reciprocal to isolate the variable. What's isolate mean?
Get by itself.
Get by itself. Okay. So if there's a fraction in front of the variable, like 3/5 k, we're going to want to multiply by the reciprocal to isolate it. Okay. So Toad, pick a color.
Dark blue.
Okay, sounds good. So we're going to solve this equation. 3/5 times k equals 6. 3/5 k equals 6. So there's a fraction in front of it, isn't there? So what's it tell us to do? Multiply by the reciprocal. What's the reciprocal of 3/5? Oh, Tucker?
5 over 3.
5 over 3. I was struggling with the name for a moment there. So we're going to multiply by 5 over 3. And we're going to do it to both sides. Now what happens with this 5 and this 5 on the left side? They reduce or simplify. They become 1. Okay. What happens with this 3 and this 3?
They don't cancel.
They don't
They turn
cancel.
into 1.
They go to 1, they reduce to 1, they simplify to 1, they divide out. So we're just left with 1 times 1 times 1 times 1, so 1 times k. So just k. It's like you send someone a long message. Okay. Now it might be helpful for us to think of this 6 as what? 6 over 1. Can we reduce anything before we go on and multiply? Sure you could. Okay. Does something go on both 6 and 3? Yeah, 3 does. Okay, how many times does 3 go to 6? 2. How many times does 3 go to 3? 1. Now you have 2 times 5 is 10 over 1 times 1, so just 10. Now if you didn't reduce that, you would get 6 times 5 is 30 over 3. What is 30 divided by 3 though? 10. You get the same thing either way. Okay, you get the same thing either way. And we can go through and check our solution here as well. Okay, we can check our solution here. Okay, 3 over 5, 3/5 times 10 equals 6. Also 10 over 1. Before we get our numbers big and then have to simplify down, we can simplify it early. We can simplify before we multiply. There's something going about 10 and 5. Anything going about 10 and 5?
Yeah.
What? 5. How many times is 5 going to 5? Once. How many times is 5 going to 10? 2. 3 times 2 is? 1 times 1 is 1, so it's over 1. Does 6 equal 6? Bada bing, bada boom. Checks out. Okay, questions on that one? Lady. Okay? I want you guys to try number 2. Negative 1/4 is equal to 2/3 b. Once again, when you have it or have questions, raise your hand.
Look at my paper, Mr. Burrow. Okay, I got it. This one I did it.
Oh, there you go.
if like you kind of pull the top a little bit more than the bottom, sometimes it helps with those too. Have you tried pinching the nose piece around your nose more?
Yeah.
Okay. Very good.
I think you did it right if you're wrong. Do I want help? Yeah. Hold on.
Five would be reciprocal. Multiply by the same thing, so we can multiply by what?
Oh.
There you go.
Let's talk about this one up here. So we're gonna multiply by what on this side? Not 2/3, but 3/2, the reciprocal. Because what's gonna happen with the reciprocal when it multiplies, the 2 is gonna simplify, the 3 is gonna simplify, and we're just gonna be left with b, which is exactly what we want. We're gonna multiply this one by 3/2, the same thing. Now we can't reduce anything early because nothing goes into both 3 and 4. Okay? So we have 3 times a 1, so that'd be 3. 2 times 4 is 8. But what can't we forget? Negative. That's the positive times the negative there. Negative 3/8 is our answer. Okay? Once again, you go through and check it. Okay? You go through and check it and say negative 1/4 equals 2/3 times negative 3/8. Well, we can simplify the 3 and 3 to 1 and negative 1. So we can simplify the 2 and 8 to 1 and 4, because 2 goes into both of those. So negative 1/4 is equal to 1 times negative 1 is negative 1. 1 times 4 is 4. It's equal to itself. Yep, that checks out. Questions on that one? Now, before I send you just to number 3, what might we have to do on number 3 first? Turn this mixed number into an improper fraction. After you turn this mixed number, negative 1 and 3/8, into an improper fraction, you can do the same exact thing you did on 1 and 2. Okay, so just make sure you turn it into an improper fraction first. Okay, I'm going to go ahead and try number 3. Let's see, when you have it or have questions, raise your hand. Good luck today, ladies. Good try though, because then you can save yourself time later.
Wait.
Very good.
Yeah, man.
first.
Hey, do you need to be checked, buddy? Do you need to be checked?
Very good, very good.
Oh.
Alright, so let's talk about number 3 together here, okay? -1 3/8 k. Well, 1 times 8 is 8, plus 3 is 11. So this is really the same thing as, let me change colors here. Emily, what color do you want? Okay. So this is really -11 over 8, okay, is equal to 2/3.
You have rating on.
Thank you. So we're going to multiply by the reciprocal, which is going to be -8 over 11. It still needs to be negative. So this -8 and this 8 will simplify. -1 and +1. 11 and -11 will simplify to -1 and +1. What's a -1 times a -1? Positive. So we're just left with k. Equals 2 over 3 times -8 over 11. Can't simplify anything there, unfortunately. So 2 times -8 is -16. And what's 3 times 11? 33. -16 over 33, and we can't simplify anymore. Okay? And I'm not going to have us check this one right now just for time's sake, okay? But we know how to, don't we? Questions on that one? Okay? Let's go ahead and flip the page here. Now we're going to practice with division. So we solved multiplication. Now we're going to do division, okay? And why don't you pick a color for me?
Blue,
Which one?
light blue.
Okay. Solve each equation, check your solution. 11w equals 143. What's happening with 11 and w right now? Multiplying. Why are they next to each other? How do you undo multiplication? Division. We're going to divide by something. What are we going to divide by? 11, whatever's there. Because 11 divided by 11 is
11.
nope. 11 divided by 11 is 0. Nope. 1. Any number divided by something is 1. Now it's 1 times w. W.
I think it was,
Dylan Dowell?
Yes.
It sounded like Dylan Dowell. I didn't see him at all.
That is wrong.
I know his voice enough at this point. I had him last year. He talks enough, so I know it. So we'll need to do 143 divided by 11. Does anyone know that off the top of their head? Me neither, okay? Does 11 go into 1? Does it go into 14? How many times? Once. 1 times 11 is 11. 33. Hey, does 11 go into 33?
Yeah.
3 times, exactly, right? That helps us out. So how many times does 11 go into 143? 13. So W is equal to 13. And we go back and check it by multiplying 11 times 13 and saying that equals 143. Once again, we might not know off the top of our head, so let's try it out. Okay, 11 times 13. What's 3 times 1? What's 3 times 1 again? Okay. Add a 0 for our placeholder. What's 1 times 1? What's 1 times 1? Add them together. 3 plus 0 is 3. 3 plus 1 is? And 1 is 1. 143. So does 143 equal 143?
Yep.
And it checks out nice and easy there, okay? Question on that first one. Alright, well, you guys try number 2. Negative 8x times equals 26. Negative 8x equals 96. If you haven't or have questions, raise your hand. Very good, thank you. Sorry, I had
No.
Eleven divided by 11, buddy?
I know it's one.
There you go.
Not fast.
Yeah, you were walking
One
by
word.
and you're like, who was that? And I was like, I don't know, but it sounded like, you're like, no, no, you're like, yeah, it sounded like Dylan now. I didn't even see him, but I know his voice enough because he talked to us last year.
Oh, cause you did
Alright,
your
have fun.
Yeah, you too,
subtraction
buddy.
and you just pulled it down.
I see.
It's bad. I just got called Brandy. It's bad when I can understand the way you're thinking.
Yeah.
Brandy,
Randy.
miniature Brandy. I do that so I don't have to feel old. You. I like your mask, Tucker.
I can't see it.
You know, the one thing that I found that I have a horrible bad habit of doing,
What's that?
now that I have the mask, I lick my finger when I'm doing my paper.
I know!
My goodness.
I
I'm gonna have to get that tacky finger stuff so we can rub our finger on
I was raging the other day in class because I was at the store and I was telling them about it. I was like getting one of those produce bags. You know, like you go and put your apples in or something like that. And I was like trying to open one of those produce bags. I'm like, I can't lick my fingers. How am I supposed to open the dang produce bag? And so I'm sitting there like for like a minute, like just like rubbing them together. I feel like I'm playing the world's smallest violin between my fingers trying to open this bag. And it's struggle busted. Oh man.
Isn't that bad that we lick our fingers though?
I don't know. I mean, maybe.
I guess it's gonna be your apples or, but I do it with the kids' paper.
Oh, I do it with papers all the time.
Yeah.
Constantly. Sounds like perfect.
Builds immunity.
Builds immunity.
Yeah, I'm just worried for helping them out.
It does.
We're helping them out. All right.
Now we're all gonna be sick when we're done with these, go licking our
Yeah.
fingers and doing our papers.
Yeah. Lainey, have I had you pick a color today?
No.
Okay, you want to pick one? Okay. Negative 8x equals 96. What's happening with negative 8 and x? Multiply it. Aiden, how do we undo multiplication? Division, what are we going to divide by? What kind of 8? Negative, whatever is there.
Good job.
Because negative 8 divided by negative 8 is 1, so we're left with 1 times x, aka x. 96 divided by negative 8, okay? So we know a positive divided by a negative will be a negative. And if we need to, we can do this 96 divided by 8 off to the side. Does 8 go into 9?
Yes.
How many times? Once. 1 times 8 is 8, subtract 1, 6. 8 goes into 16? Twice. It is 16. So x is negative 12. And we can go back and check our work and say 8 times negative 12 equals 96. Well, we can go through and prove 8 times negative 12. You can really just think of it as knowing it's going to be a negative. I mean, negative 8 times negative 12. Knowing it's going to be a negative there. 8 times 2 is 16. 8 times 1 is 8 plus 1 is 9. So it's negative 96, which is actually positive 96 because the negative times a negative. I misspoke again. Equals 96, and it does check out. Question on that one. Okay, on this last one, negative 0.42 equals negative 3 over s. Decimals, ooh, are we going to be scared of decimals?
No.
Yeah, we're not going to be scared of decimals. We'll show those big bad decimals what's up, okay? So, Reagan, you want to pick a color?
Green.
Green, alrighty. So, what is happening with our variable s right now? We are doing what? Multiplying. How are we going to do that? Divide by negative 3. So, what's negative 3 divided by negative 3? 1. So, it is with s. What's a negative divided by negative going to be? Positive. So, we know our answer is going to be positive, okay?
Just checking, make sure you got.
Does anyone know what 0.42 divided by 3 is off the top of their head? Maybe not, okay? So if I have the 3 outside here, okay? Then I have 0.42 inside. What do I do with this decimal? Does anyone know?
Move it up.
Okay, we just move it up. Okay? If I had a decimal over here, I'd have to move it and move this decimal too, but I just move it up. Does 3 go into 4?
Yep.
How many times? Once. What's 3 times 1?
3.
3. What's 4 minus 3?
1.
And drop the 2. Is 3 going to 12? How many times? 4. And it is 12. So our answer is 0.14 or 0.14. If I ask you, hey, how many times does 3 go into 42, would you guys know it's 14 or no? Okay. If you would, you can do the same kind of principle we did with the multiplying earlier and say, oh, 3 goes into 42 14 times, 0.14 instead. If not, that's okay. We can go back and check our work, but I'm not going to make us in this one. But we totally could, right? We can do negative 3 times 0.14 again. We can multiply decimals. We learned it really isn't that bad. You just have to move the decimal back at the end. Questions on these? All right, last problem for the notes. Write an equation for the problem below and solve the equation. Negative 14 times the number equals 224. Negative 14 times the number equals 224. I want everyone to try writing the equation on their paper. I want everyone to try to write the equation on their paper and then hold, okay? Once you have the equation written, raise your hand. Once you have this equation written, raise your hand, okay? There you go. Solve. What you got?
Okay, now I understand this.
Good.
Yeah.
I didn't understand for the longest time, and now I'm just
Over.
Do you guys think this is starting out easier than what we did last year?
Yes.
Yeah.
Okay, good.
Lot.
Well,
A
those
lot.
lines
Go
there.
and start solving it.
Huh?
Go and start solving it.
Oh, okay.
Go and start solving it.
You guys just seem like you're not like that. Not what?
Yeah. I think part of it's because we're more awake too. For me,
What do we have it last year?
we had it like
One more
morning after band. Yeah, I know.
I missed you last night.
Baseball, softball. Baseball's in the spring. Yeah, heard his JV game was good though.
JV, I wasn't there. I don't come until 6 o'clock.
Oh, okay,
I
gotcha.
gotta work at the jewelry store.
Yeah.
But yeah, I heard Kristoff got a home run and
Yeah,
every game I've gone to so far, there's been at least one.
yeah,
Isn't that crazy?
that is crazy. That was a grand slam too.
I think, yeah.
That's what I heard.
Yeah.
Grand slam, tie it up pretty cool. Yeah, I can't come now, but because of the new guidelines. So. All right, so.
Teachers' Day or go?
No, so what, how am I gonna watch football?
Yeah.
From the parking lot, I guess. I'm just kidding.
Yeah.
No, they're working on mainstreaming it, so we could possibly mainstream it at, DJ's.
Oh, yeah. That's a good idea.
Yeah, we're working on that, Mr. Downing and
Nice. Negative 14 times the number equals 224. Okay, what's our equation for this one, Maddie?
14 times 14x
Okay, one slight adjustment that I think you did on your paper, but it's negative 14, right? Do we have to use x? No, Lainey, what did you use?
A.
Did you still do okay?
Yeah.
Okay, yeah, didn't affect it. Okay. So now how do we solve this?
Divide.
Divide, right? Because it's multiplying by negative 14. Negative 14 divided by itself is 1, so we're left with x. 224 divided by negative 14, we can do this off to the side somewhere. We know a positive divided by a negative will be a. We know a positive divided by a negative will be a negative. Does 14 go into 2? It's going to 22. Yes, how many times?
Once.
Once. 1 times 14 is 14. What's 22 minus 14? 8. Drop the 4. Is 14 going to 84? Well, we might not know how many times. Well, hey, remember that guess and check method I taught you? The little hint? You guys remember that? Okay. Take the second digit, 4, and we're trying to get it to be the 4 if it works out nicely. So 4 times what will end in a 4? Okay, 6. Okay, so we can try that. Let's try 6. Okay, so 14 times 6. 6 times 4 is 24. Haha. 6 times 1 is 6 plus 2 is 8. Hey, that worked. Did anybody use that as they were trying to solve this? It did it help you? Good, yeah. Okay, so our answer is negative 16. Okay? Can we go back and check our answer if you wanted to?
Yeah.
Sure, do you have to?
No.
No.
No, but if you have extra time, sometimes it's worth it, okay? Alrighty, well, we do have a worksheet over this as well, okay? So a big meaning has to give that homework.
Did it all my favorite color?